What is up, guys? Welcome to your 35th physics lesson, and in this lesson I want to start talking to you guys about waves. Now, unfortunately, I'm not talking about surfing. I'm talking about the waves that relate to physics. Now, in order to understand any concept like magnets, light, sound, electricity, and a lot of other physics related topics, we need to understand the concept of a wave and a wave's motion. So probably the easiest way that we can understand this is to look at a simple pendulum. Now, I know a lot of you guys already know what a pendulum is, but for those of you who don't, imagine this. Imagine you have a point, it doesn't really matter, what it is, but from that point you have a string, and at the end of the string you have some sort of weight right here. So here's your weight. Some people actually call it a bob when it's on a pendulum. But that's all a pendulum is, a weight hung from some point that can swing freely back and forth. Now, of course, in these examples, just go ahead and pretend that the string, which is right here, pretend that it has no mass whatsoever. And also that, you're not losing any friction, from the weight hitting the particles in the air or, the string rubbing against this point. This would be the idea of a perfect pendulum. Now, of course, building this perfect pendulum would be impossible to build in real life, but just to demonstrate these concepts in physics, it's important to understand that the string and weight are, well, the string is massless and the weight doesn't cause any friction. So the first thing I want to talk to you guys about is a period. Now, probably all you girls already know what this is. They talk to you about that in health class, but in physics class, a period means something else. The period is the time it takes for this pendulum to basically complete one swing back and forth. So that's basically all a period is. It's pretty much just a definition that we have to remember because I'm going to be bringing up the term period a lot, and I don't want you guys to think like it's something else. So a fun fact that you guys have to remember is the longer the string, the longer the period, or the more time it takes to swing back and forth. So again, that relationship one more time is the longer the string, the longer the period, aka time it takes to complete one swing. Now, another relationship that you have to remember is actually more like an interesting fact. Now, this weight right here actually has no effect on the period at all. So if you put a pumpkin right here, or you put a baseball, or, maybe a blueberry, it doesn't matter at all. The weight of the object doesn't affect the period or the time of the swing whatsoever. Pretty interesting, eh? So now that we understand, what a pendulum is, the string, the weight, the period, let's go ahead and I want to talk to you guys about a few calculations that are going to come in handy. Now in these calculations, I'm just going to symbolize T, that kind of looks like an F, I'll draw my T a little bit better. T equals period. And the reason that we can use T is because period is basically time, so that's why I use T. L equals length of the pendulum. Now, whenever you are measuring a pendulum, remember I said you have a point right here and you have a big weight. You're thinking, do I measure it from the top of the weight right here, the bottom of the weight? You actually measure it from the middle of the pendulum right here. So this is the correct spot. I'll name this the G spot because that is the good spot. G stands for good. So this point, point A to point B, or the G spot, is where you measure the pendulum, and that gives you your L. And last but not least, you got G. And G, of course, symbolizes the gravity. So T is the period or length of time it takes for the pendulum to complete one swing back and forth. L is the length of the pendulum from A to the G spot, and G is the gravity. So I probably shouldn't have named that G spot. It may confuse you guys. But now let's go ahead and look at a formula to calculate the length or period. That's T, all my T's look like frickin' F's. T equals 2 pi, or 2 pi's if you're a baker, the square root of L over G. So we already know two of the values whenever we want to calculate T right here. And remember, T is basically, this is the formula you use whenever you want to calculate how long a pendulum takes to complete one swing. So, well, let me go ahead and throw in some figures first. Say that we want to try to find the period of a 5-meter long pendulum. Question mark. So let's see what values we have so far. Well, t, that's going to be a question mark because that's what we're trying to figure out. 2 pi, of course, 2 is 2 and pi is 3.14, and L is length, so that's 5 meters. And we already know G as well, that's 9.8 meters per second squared. So if we want to go ahead and calculate this, what would you do? Well, we would just go ahead and really the only thing we need to figure out right now is this right here, L and G. So the square root of L, which is 5, and G, which is 9.8, first you do 5 over 9.8, and then you take the square root of that, and you find that this is equal to 0.714. So that's what this is in the blue circle. So now all we have to do is take this value, 0.714, and times it by 2, and times that by pi, which is 3. Well, I'll just go ahead and write the symbol. I'm too lazy to write all those numbers. And when we multiply all these together, we get 4.4879 seconds. So if anyone asks you, and trust me, they do ask you this a lot, hey Bucky, how long is the period of a 5-meter long pendulum? OMG, if I had a nickel for every time anyone asked me that, I would have like 2 nickels because, to tell you the truth, I would have no nickels. This is useless. Don't ever use this formula again if you're not in a physics setting. But anyways, if someone does ask you that, then you can say proudly, the length of a period, or the time it takes a 5-meter long pendulum to swing back and forth, is 4.4879 seconds. So there you go. That is what a pendulum is, and that is also what a period is. And now that we are armed with this knowledge and also the formula of how to calculate the length or period of a pendulum, we can now move on to the next topic, understanding more concepts concerning waves.